Good morning. We're going to go ahead and get started. Please let me know if you can hear me by typing ABC into the chat box. And remember to post your name or alias, the day and time of your class, and your, oh, actually that's all you need if you're watching live. If you're watching a recorded version, you also need to post a quotation from the video, something to do with math content. Okay, I think we're up and running. I don't see anybody posting. Can you post ABC if you hear me? Okay, so let me know if you can't hear me. You can type a message into the chat box. But I think the sound is working, so I'm going to go ahead and get started. Today, our live chat is about rational exponents and radicals. So when you see the word rational in math, focus in on the root of the word ratio, because all that it means is a ratio, a fraction. So it's a fraction and an exponent in this case. Now it turns out that even if we have fractions in our exponents, all the rules of exponents that you've learned before should still apply. Let's review those rules and look at a couple examples, and then we'll look at some examples where we have fractions in our exponents, and we'll see that it works the same way. All right, so the first rule, and by the way, all of this that we're looking at right now is in your OneNote folder, your OneNote notebook, I should say, in the live chat folder under day 10.5, objective 9, rational exponents and radicals. All right, so let me zoom in a little bit. Get a little bit bigger here. So the first rule of exponents that we're going to review, and we're not looking at these in any particular order, is just a to any number a to the power 0 is equal to 1. Any number to the 0 power is equal to 1 right here. Okay, and the second rule is, that's called the zero exponent rule. The second rule is called the power rule, or powers to powers. So when you raise a power to a power, you multiply the exponents. Oftentimes, this is going to be used in combination with the following rule. If you have two numbers, a and b, being raised to a power, and their product is being raised to a power, you can just raise each part of that product to a power. All right, so with those, let's start with those three rules. We're going to practice several rules, but we're going to start with those three. And we're going to look at some examples. So first, anything to the 0 power is 1. When you raise a power to a power, you multiply the exponents. And when you raise a product to a power, you can raise each part to that power. So let's look at a couple of examples. So first, we have 3 to the 0 power. So as we just said, anything to the 0 power is 1, so you would just write a 1. Okay, the next one looks harder, but it's really not. Because when we're talking about exponents, and by the way, in the expression 3 to the 0, For example, 3 is called the base, and 0 is called the exponent or the power. So in this expression, 5 times x to the third y to the fourth, since the whole expression is inside of parentheses, that whole thing is the base. And the 0 is affecting whatever's in the parentheses, the base. So even though we have this great big giant expression being raised to the 0 power, we still just get 1. Okay, let's do another one using the powers to powers idea. So x to the 5th raised to the 4th power. So when you raise a power to a power, you multiply the exponents. So that's going to give us x to the 5 times 4, which is x to the 20th power. Okay, now I told you this powers to powers idea is often used in combination with the fact that when you raise a product to a power, you can just raise each part to that power. So what I meant by that is in an item like this one, 2x to the 4th y squared raised to the 3rd power. The whole thing's being raised to the 3rd power. And we can break that down since these are all being multiplied. That's important. This doesn't work for addition and subtraction, but since they're all being multiplied, that's the same as raising 2 to the 3rd power, x to the 4th to the 3rd power, and y squared to the 3rd power. We usually don't write that step. We just kind of imagine raising each part to that power. But in any case, that's what we're thinking. And then 2 to the 3rd is 2 times 2 times 2, so that's 8. X to the 4th raised to the 3rd power. This is raising a power to a power, so we multiply the exponents, we get x to the 12th. And y squared to the 3rd, again, raising a power to a power, we multiply the exponents. 2 times 3 is 6. So we get 8x to the 12th, y to the 6th. I want to show you one more. So this is a quotient raised to a power. I didn't actually write out a rule for that, but the same thing applies. If the only operation here is to divide, remember division is really just multiplication written in a sneaky way, but in any case, we can raise each part to that power. So x squared to the 4th over y cubed to the 4th. Then we can use our powers to powers idea. So raise a power to a power, multiply the exponents, we get x to the 8th over y to the 12th. All right, so we've applied several rules of exponents at this point. Let's go ahead and look at a few more. Okay, so I'm going to scroll down. I'm going to see a few more here. Actually, let's just do these two. Okay, so we're going to next do the negative exponent rule. The negative exponent rule looks like this. If you raise a number a base a, to the negative n power, then that's the same as putting 1 over a to the n power. In other words, the negative sign tells you that you're on the wrong side of the fraction bar. It needs to be flipped. Now this works regardless of whether you start with the negative n on the negative power on the a, or perhaps you start with a negative power in the denominator, 1 over a to the negative n. You still just flip it up to the top, or in other words, make it a whole number this time, and you get a to the n. We never leave a negative exponent in our answer, so we often have to switch the sides. If we're doing operations and end up with a negative exponent, we have to flip it around. I also want to remind you that when you multiply like bases, meaning the same base, to being raised to whatever powers, when you multiply those two expressions, you can just add the exponents together. And another one says, and I need to scroll a bit for this one. So that was the product rule when we're multiplying like bases. In this case, we're dividing like bases. A to the m over a to the n, you subtract the exponents. So multiply goes with adding the exponents. Dividing like bases goes with subtracting the exponents. Now, it is important which exponent comes first in this expression. So it's the top minus the bottom exponent. But if you want to, you can reverse that. But what that means is it's the opposite sign on the exponent, so you have to put it down on the opposite side of the fraction bar. So if you choose to do bottom minus top, a to the m over a to the n is going to be 1 over a to the n minus m. So notice we're doing bottom exponent minus the top here, so it's flipped. Okay, so let's keep these in mind and look at a few more specific examples. Okay, so the first one we're going to look at, we're going to have 5. Oh, good. Janice, you posted your name and class. Thank you. We're going to do 5 to the negative 2 power. All right, so again, we don't leave a negative in the exponent. So what this is telling us to do is to flip it and make it 1 over 5 squared. Notice that this is 1/25, which is a positive number. So the negative in the exponent does not mean that your answer is going to be a negative value. How about 4x to the negative 2? So this one is a little bit tricky because you have to keep in mind that the exponent only affects what's immediately in front of it, or immediately to the left of it, in other words. So we have a 4 being multiplied by 1 over x squared. Or another way of saying it is you keep the 4 in the numerator and bring that x squared down to the denominator. This is the preferred way to write the answer most of the time here. Okay. Now, this is very different from the situation where you have 4x in parentheses to the negative 2 power, because now the negative 2 is affecting everything in the parentheses. So in that case, we would have 1 over 4x to the second power. And since this is a product, we can just raise each part to that power. 4 squared is 16. X squared is just x squared. So this is 1 over 16x squared. So these are two different results here, right? Because in one, the exponent was only affecting the x, and the other it was affecting everything. Okay, let's look at another one here. We have x to the negative third over y to the negative 7. Okay, so you could go one step at a time, and you could say, okay, I'm going to leave my x to the negative third there. I'm going to bring this y to the negative 7th up top, make that positive, and then bring the x down. But you don't have to do that. You can just switch them. So when you see they both have negatives, you can just flip it over and make the exponents positive. Okay. How about x times x to the 5th? So this is an example of the rule of when you're multiplying like bases. The bases here are each x. Now one of the exponents is actually invisible. When there's no exponent written, though, there is a power. That's a power of 1. So when we multiply like bases, we add the exponents. So that would be x to the 1 plus 5, which would be x to the 6th. Now these rules might seem random to you, but they're really not. You can prove what I'm telling you is true about these rules. This one's particularly easy, I think, for most people to understand, because x to the first just means 1 copy of x. X to the 5th means 5 more. So how many copies or factors of x do we have altogether? We have 6 of them. So you can see why we get x to the 6th. Okay, but we don't want to have to write that all out. So we memorize the rule that when you multiply like bases, you add the exponents. Same thing here, y to the 4th times y to the 9th. They've added 4 and 9 and got y to the 13th. Okay, do you remember the rule from when we're dividing like bases? Remember we said to subtract. So let's start with x to the 5th over x cubed. Okay, so first I'm going to show you the long way, like I did a minute ago with the product up there. If we have 5 copies of x over 3 copies of x, 3 of the copies of x are going to cancel out, leaving us with just x squared. You can write x squared over 1, but we don't want to leave with that in our final answer. So I'm just going to write x squared. But notice that that is exactly 5 minus 3, the top exponent minus the bottom. All right, now let's see what would have happened if we had chosen to use that other rule I told you about, where you do bottom minus top but leave it in the denominator. So if you do that, you're going to have 1 over x to the bottom exponent minus the top. That would give you 1 over x to the negative 2. And of course, we're not going to leave a negative 2 in our answer. So we are going to flip it over, and it still becomes x squared. So either way you work it, you're going to get to that final answer. That's the same if you do everything correctly. So in this case, if you leave it in the bottom, you're going to go bottom minus top. If you leave it in the top or as a whole number, you get top minus bottom. Okay. All right, so let's look at a couple more problems and see. All right, so here's a good example, y to the 4th over y to the 9th. Okay, if you do top minus bottom, you leave it as a whole number, or in other words, leave it in the top. You have y to the 4 minus 9, which equals y to the negative 5th. But then since that's a negative, you have to flip it back down to the bottom. So top minus bottom is a little bit longer than if we had gone the other way. So if we did bottom minus top and leave it in the bottom, we have 1 over y to the 9 minus 4, which would be 1 over y to the 5th. And sometimes students ask me, do we really need this 1 over? Yes, we do. Y to the 5th is a different number than 1 over y to the 5th. For example, if you had 1 over 2 to the 5th, that would be 1 over 32, whereas just 2 to the 5th is 32. Those are two different numbers. If you take away the 1 over, you're actually making an error. So yes, you need that 1 over. We just don't need the 1 when it's in the denominator. Okay. All right, so let's see if this last item here, can you see how they got the answer x over y to the 3rd? We have x cubed y squared over x squared y to the 5th. Now there's more than one way to get to that answer, but if you apply the rules that we've discussed correctly, you should come to that conclusion. So take a moment and think about how you would do that. Okay, did you figure it out? Write something down so that you can see, kind of test yourself and see how you're understanding. All right, so let's take a look, and we have, I'm going to rewrite it. Oops. All right, so we have x cubed y squared over x squared y to the fifth. All right, so I'm going to, for the x, since the bigger exponent is in the top, I'm going to do top minus bottom and leave the x in the top. So we're going to have x to the 3 minus 2 over. And then for the y, since the bigger exponent's in the bottom, I'm going to do bottom minus top and leave it in the bottom. So that's going to be y 5 minus 2. So that's x to the first over y cubed, or in other words, x over y cubed. All right, now a lot of you probably don't really need to even perform that subtraction. You're probably so comfortable with this that you can just look at this and think of things, quote, canceling. Of course, what canceling means in different situations varies, so you have to be careful how you throw that around. What you really mean is that there were 3 copies of x canceling with 2 copies of x, which leaves just the 1 copy of x. And then there were 2 y's canceling with 2 of the y's down here, leaving 3 left over. So you're still going to get x over y cubed, thinking of it that way. But what you're really doing when you simplify a quotient of monomials like that is you are using the quotient rule. A to the m over a to the n equals a to the m minus n. Okay, so let's look at a few more examples down here that I got from your Alex assignments. And it says evaluate the expressions. And we're going to use, again, a combination of the different rules. So it should only take a moment to work these exercises. So I'm going to just pause for just a moment and you jot down what you think the answers are. Okay, so remember, when you raise anything to the 0 power, you're going to get 1. In this case, only the 1/5 is being affected by the 0 exponent, right? So that doesn't look right. Let's see here. So when you raise 1/5 to the 0 power, you get 1. So we're going to have just -2 times 1, or -2. And then over here, the 7 is affected by the 0, but not the negative. So the negative sign tags along, and you have -1. Okay, let's look at some more. All right, on this one, I just want to remind you of the difference between when parentheses are included and when they're not. So, for example, here, If you have negative 4 to the third power, the whole thing is affected. So that's like telling you to multiply negative 4 times itself 3 times. So a negative times a negative times a negative, when you have an odd number of negatives, you're going to get a negative. If you have an even number of negatives, since a negative times a negative is a positive, then if you have an even number of negatives, that's going to give you a positive. In this case, we have 3, an odd number, so we're going to get a negative answer. And then you just find 4 to the third power. 4 times 4 times 4, which, let's see, that's going to be 64. Okay, now this is different from this next one where we have a negative that is not being affected by the 4, only the 2 is. So that's the same as negative of 2 times 2 times 2 times 2, right? Or 2 to the fourth, which is 16. So you get negative 16. Okay, so let's compare that to these two problems here. So in this first one, negative of 4 cubed, only the 4 is being affected by the cubed. So we know that 4 times 4 times 4 is 64, so we get negative 64. Notice it's the same, even though we didn't have parentheses, it turned out the same. That's because we have an odd power, which keeps the sign the same as whatever it was. But on the other hand, when we have negative 2 to the fourth power, we have an even power affecting the whole thing. That you don't have to write this out, but just to be clear, this is the same as multiplying out negative 2 4 times. But an even number of negatives gives you a positive. So that means that we are going to have a positive number version of 2 to the fourth, or 16. So in this case, we got 16, not negative 16. So you really have to watch out for those even powers, because it can change a negative number to a positive if the negative is in parentheses. But if it's not, it's going to just leave it alone. Okay, let's look at another one. All right, so what I like about this problem is people definitely choose different ways to go about it. I think that makes people nervous that there's more than one option, but just go with it. Apply, as long as you apply the rules correctly, just take it one step at a time. Let's see, if we're simplifying this, one person might say, oh, you know what, I'm never supposed to have negative exponents, so I'm going to go ahead and flip it over. So you'd have 1 over v to the 8th times 1 over v cubed, or in other words, 1 over v to the 8th v cubed. And then they might say, okay, when I multiply like bases, I add the exponents. So that would be 1 over v to the 11th power. Okay, now another person might have done this differently. They might have said, when I multiply like bases, I add the exponents, so I get v to the negative 8 plus negative 3, or in other words, v to the negative 11th power. But then they would say, okay, I'm not supposed to leave a negative in my exponent, so I'm going to put 1 over v to the positive 11th. You get the same answer either way. All right, so remember our goal was to be able to work with exponents that are actually fractions. Those are called rational exponents. So in this case, we have a rational exponent being raised to the power of a rational exponent. You still use the power of a power rule, right? So when you raise a power to a power, you do what? You multiply the exponents. So we're going to change this from raising a power to a power to multiplication of the exponents. Y to the power of 9/4 times 10/7. And we multiply straight across, but remember we do have the option of reducing first anything in a denominator with any factor in the numerator. So that's going to be 9/2 times 5/7. All right, so multiplying across then we have y to the 45/14. Okay, it's not pretty, but that is what it's equal to. All right, here's another one where we have a variety of options of what to do first and second. I will tell you that when I see operations involving products of like bases and fractions in the exponents, if I see that there is a common denominator already between these two powers, I would probably work with these two first rather than start with the 1/3 in one of them. So I'm going to start with this. Remember, like bases being multiplied, you add the exponents. So this is the same as x to the 5/4 minus 1/4, which, since they have a common denominator, will be relatively straightforward to calculate. So that means we're going to get 5/4 minus 1/4 is 4/4, or 1, and that's over x to the 1/3. Now we need to subtract, and since the larger number's in the top, I'll go ahead and do top minus bottom. So we're going to have x to the 1 minus 1/3. The top exponent minus the bottom, so that's why I'm writing it as a whole number. And then that is going to be x to the 2/3 power. Okay, now, so, one more. So maybe try this one at home. I do want to remind you that if you're using the TI-30 X2S at home, which you should be, that it does have a fraction key. So it looks like AB over C and gives you your fraction bar. So for example, if you wanted to type 2/5 into your calculator, you would hit 2 AB over C and then 5, and that would be your 2/5. And you can do that and perform operations with other fractions. Okay, so hopefully you started at home. And so what do we need to do? When you divide like bases, you can subtract the exponents, right? So that's going to be u to the 2/5 minus 2/3. Now I'm going to work this out by hand, but again, you can use the AB over C key to make fraction bars, so you can perform this subtraction on your TI-30 X2S calculator as well. So we're going to have to get a common denominator of 15. And so this is the same as u to the, let's see, we're doing times 3 here. So it's going to be 6/15 and times 5 here. So that's going to be minus 10/15. So that's going to give you u to the negative 4/15. But we don't leave negatives in our exponent. So it's going to be 1 over u to the 4/15. Okay. All right. Now let's talk about what the heck these fractions and exponents mean, right? Because we know that, for example, 2 cubed is 2 times 2 times 2. But what does 2 to the 3/4 mean? Or 16 in this case to the 3/4. So it turns out that what this actually is is the denominator gives you the index of a radical, and the numerator gives you a power. So here's what I mean by that. 16 to the 3/4 is the same as 16 to the 1/4 to the third, right? Because when you raise a power to a power, you multiply exponents. All right, so this 1/4 is telling you to take the fourth root of 16, and then raise it to the third power. So fourth roots are kind of tricky. We aren't as familiar with fourth powers. Or remember, you can always work with fourth roots or fifth roots or whatever by making a list of perfect powers of 4 or 5 or whatever the index is. So, for example, 1 to the 4th is 1, so 1 is a perfect fourth power. 2 to the 4th is 16, so 16 is a perfect fourth power. 3 to the 4th is 81, so 81 is a perfect fourth power. But we don't have to keep going, because notice that 16 was a perfect fourth power. So if you want to simplify the fourth root of 2 to the 4th, because 16 is equal to 2 to the 4th, what would that be? So this is asking what raised to the fourth power gives you 2 to the fourth power. So the answer to that is 2. So in other words, these canceled out. Taking a fourth root is reversing the operation of raising to the fourth power. And then 2 cubed is 8. So in reality, 16 to the 3/4 power is just 8. Now we don't usually write out this extra step. We usually just skip directly to translating it to this guy here. Okay. So remember, when you have a fraction in your exponent, the numerator or top of the fraction is the power, the denominator or bottom of the fraction is the index of the radical. All right, so let's use this idea to simplify these expressions. I'm going to start with 625 to the negative 3/4 power. So the first thing I have to give you a heads up about is that you never try to deal with the roots until you've dealt with that negative in the exponent. So just go ahead and rewrite it automatically with a positive exponent, 1 over 625 to the 3/4. Then and only then will you switch to radical notation. So remember, the top of the fractional exponent is the power, the bottom is the is the index of the radical. So that's going to be 1 over the fourth root of 625. Now, by the way, it doesn't matter if you put the power on the outside of the radical or on the inside, just not both, of course. But which one would be easier? Well, the inside one would not be easier because you'll get a huge number when you raise 625 to the third power. It's better to do the radical first. That's going to give you a smaller number, and then we'll deal with the exponent in a minute. So to do the radical first, we would say 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th is, what is that? Let me get my calculator out. I'm blanking out on that one. 4 to the 4th power is 256. And then 5 to the 4th power is actually 625. So when we take the fourth root of 625, we're really taking the fourth root of 5 to the 4th power. So these cancel out. So we're just going to have 1 over 5 cubed, which is 1 over 125. So that's how you evaluate expressions that have a rational exponent, a fraction in the exponent. Okay, I think that's all we're going to look at today. So I hope you have a good weekend. Please give this video a thumbs up if it was helpful. That helps other students to find the video. And if you're one of my students watching the recorded version, remember you still can get bonus points by just posting a comment. The comment must include your name, which day and time your class meets, and a quotation of some sort from the video regarding mathematical content. Have a great weekend.